The reframing technique. This strategy involves changing the way you look at a problem. Often, the way a problem initially framed can limit the possible solutions. By consciously shifting your perspective, you can uncover new angles and potential pathways to resolution. So, how it works? First, identify the initial framing. How is the problem currently being defined or understood? Then, challenge the framing. What assumptions are embedded in this frame? Are there alternative ways to view the situation? Then the third, reframe the problem. Try looking at it from different viewpoints. Focus on the positive aspects instead of the negative. Consider the problem from the perspective of different stakeholders. Broaden or narrow the scope of the problem. Think of the problem as an opportunity instead of a threat. So, how it helps? Reframing can unlock creative solution by breaking free from limiting perspectives. A problem that seems impossible under one framing might become solvable when viewed from different angle. For example, instead of seeing low customer engagement as a problem, you might reframe it as an opportunity to build a stronger customer relationships.
Let's explore the refraining technique in mathematics through an example. You have a rectangular garden that is 10 meters long and 5 meters wide. You want to increase the area of the garden by 25 square meters by adding the same width, say x, to both the length and the width. What is the value of x? Our initial instinct might be directly translate the problem into an algebraic equation based on the given information. The original area of the garden is 10 times 5 equals 50 square meters. After increasing the length and width by x, the new dimension will be open and close parentheses 10 plus x meters and open and close parentheses 5 plus x meters. The new area will be open and close parentheses 10 plus x and open and close parentheses 5 plus x square meters. We are told that the new area is 25 square meters more than the original area. So the new area is 50 plus 25 equals 75 square meters.
Expanding and simplifying this equation, x equals 2 times 1 minus 15 plus or minus the square root of 15 squared minus 4 times 1 times negative 25 all over 2 times 1. This simplifies to x equals 2 minus 15 plus or minus the square root of 225 plus 100 all over 2. Further, simplifying x equals negative 13 plus or minus the square root of 325 all over 2. Finally, x equals negative 13 plus or minus 5 times the square root of 13 all over 2. We can solve this quadratic equation using the quadratic formula. Starting with the general quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, substituting the given values of a, b, and c, where a equals 1, b equals 15, and c equals negative 25.
Let's reframe the problem by visualizing the increase in area. When we add a width x to both the length and the width, the increase in area can be seen as three additional rectangular regions. First, a rectangle with dimension 10x times along the original length. Second, a rectangular with dimensions 5x times along the original width. Third, a square with dimension x times x at the corner. The total increase in area is the sum of the area of this tree region, which we know is 25 square meters. So we can express the increase in area as 10x plus 5x plus x2 equals 25x2 plus 15x equals 25x2 plus 15x minus 25 equals 0. Notice that this reframe approach leads to the same quadratic equation we obtained earlier. However, the way we arrive at the equation is different. The reframing provided a visual and conceptual understanding of how the area increased. breaking down the problem into a simpler component.
Instead of directly calculating the new area, we can focus on the difference in area. The increase in area is 25 square meters. This increase comes from adding strip along length and width, and the small squares at the corner. Let the original length be L equals to 10 and the original width be W equals to 5. This increase in length and width is X. The increase in area is given Y. Again, we arrive at the same quadratic equation.
The reframing technique in mathematics involves looking at a problem from a different perspective or representing it in a new way. In this example, we reframe the problem by visualizing the increase in area. This helps us break down the problem into the sum of simpler areas. Focusing on the difference, this allowed us to directly set up an equation based on the change in area. While the reframing didn't necessarily simplify the algebra solution in this particular case, as we still ended up with the same quadratic equation, it provided a deeper understanding of the problem structure and offered alternative ways to think about the relationship between the variables. In other mathematical problems, reframing can lead to significantly simpler solutions or reveal hidden insight. The key is to be flexible in your approach and explore different ways to represent the given information.